Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience for our 2 separate question and answer periods today. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we will try to get to as many as we can. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. We also do have 4 polling questions throughout today's webinar, so hopefully we can get everybody engaged with those. All right, with that, let's go ahead and kick off today's webinar, which is preventing code tampering and verifying integrity across your software development lifecycle. Our speakers today are Ronan Slavin, who is the co-founder and CTO of SciCode, and Andrew Fife, who is the VP of Marketing at SciCode. Gentlemen, thank you so much for joining me today. Really appreciate it.
Thank you so much, Charlene. We really appreciate you having us here today. We think this is an incredibly important topic. Not only is it timely, but in general, it just sort of cuts to the core of securing your software development lifecycle. So my name is Andrew Fife. I run marketing for SciCode. I've been marketing for security startups for most of my career over the past, oh gosh, I guess it's almost 20 years now. And I'm also on the line here with my co-founder and CTO, Ronan Slavin. Ronan has deep technical expertise, having come out of Israeli Defense Forces elite 8200 cybersecurity unit and having been the CTO of a number of successful security startups. So that's about us really quickly. But before we jump into this content here, we're going to run this webinar slightly differently from normal webinars. As Charlene mentioned, we're going to actually do 2 Q&A periods, and we'll do 2 demo periods. Plus, we've got 4 poll questions. Effectively, what's going on is we're trying to attack a really dense and meaty topic today. We're going to throw a lot of information at you. And what we wanted to do was try and keep it as interactive and kind of fun as possible. So as Charlene mentioned, please feel free to ask questions at any time. Unlike a traditional presentation where you might get 45 minutes of content and then 5 or 10 minutes of Q&A, we're going to take questions in 10 or 15 minutes from now. So, those questions are going to come up soon. So please feel free to ask. But so why is code tampering and why is the integrity of your SDLC so important now? Well, first and foremost, let's acknowledge that SolarWinds has absolutely made this topic, front and center. So that is a big part of it. But what's sort of the fundamental shifts that have been happening that made SolarWinds attack possible? First, let's acknowledge also that SolarWinds is one of many supply chain attacks. It just happens to be the biggest and the most dangerous. But why are supply chain attacks starting to happen more? Well, part of it is because the software development lifecycle has changed a lot, and there are lots of tools out there that help you secure the contents and the output of your SDLC. Sometimes I like to refer to this as the alphabet soup of AppSec. And those are the tools you've probably heard of: static application security testing, interactive, dynamic, software composition analysis, WAF, RASP, container security. Those all focus on what you're actually building and how to operate it. However, we think that the development pipeline itself, the infrastructure, the tools like your source code, source control management system, your build system, your deployment system, we think that infrastructure itself is fundamentally insecure, and that is providing a whole new level of attack surface for attackers to come in. Plus, when you think about the supply chain, it's so much based on trust, and whatever we trust today, whatever we think is secure today inherently becomes insecure over time. It's a combination of the weakest link plus the fact that if we assume that something is secure, we tend not to layer in the traditional security layers behind it. And then the third thing is that everything as code has really concentrated so much of the SDLC into your code repository. So that is really elevating the status of the code repository as a target that is often not as secure as it should be, but also is really juicy. Because if you think about it today, whereas most traditional hackers have gone after the production application, trying to exploit either a zero day that they've found or maybe an insecure library that they've identified that's being run. You're trying to go kind of through the front door to get to the data. But with GitOps or everything as code, not only do you have access to the source code these days, you have access to CI/CD settings through things like GitHub Actions. You also have access to infrastructure as code. And so what you can actually do today in the source control management system is you could look at the source code, you could identify where a payment gateway is sitting, you could then modify infrastructure as code to change access to something that's highly valuable, such as that gateway, and make it public. So there's a lot of reasons why these types of supply chain attacks are happening now, and why code tampering and the integrity of your SDLC is increasingly important. Next slide. So before we get too much deeper into it, we just wanted to start with the first poll question, which Charlene, if you could fire now, is which phase of your SDLC are you most concerned about code tampering?
Okay, that polling question. Yeah, that polling question should be up on your screen now. Give everybody about, I don't know, about a minute or so to go ahead and make your decision. And while we are waiting for the audience to make its decision, just a quick reminder that we do have that two-part question and answer period this time. So please don't feel like you got to wait for the question and answer period to submit any questions that you have. You can go ahead and do that at any time. All right, we'll give you guys just about 10 more seconds and then we'll close it down and take a look at the poll results. Okay, counting down in 5, 4, 3, 2, 1. And here are the results for this first one. This phase of your software delivery lifecycle are most concerned about code tampering is in the build CI/CD phase. That makes a whole lot of sense to me. What about you guys?
Yeah, I think it makes a ton of sense, especially when you think about exactly what happened to SolarWinds and the relationship with their build server. So that makes a ton of sense that that's front and center. It is kind of interesting to see that production is so low, because in theory that's the most efficient place. If you can tamper with code in production, you've got it deployed. But yeah, Ronan, you have any thoughts?
Yeah, I agree. I think the results are interesting. Again, the SolarWinds incident is something that made us all think about our build and CI/CD tooling. And you are correct that the production environment is what currently, at least from what I know, organizations spend the most on securing and making sure that nothing happens. So yeah, definitely interesting answer. So let's.
All right, I'll go ahead and hide the results for you.
Thank you. Moving. Okay. Okay, cool. So as part of this webinar, we will use this the example that you see now on the screen as sort of an example that will guide us through this entire webinar. The idea is that we wanted to take sort of a simplified SDLC. So we would have our developers working on the workstation, developing code. They would usually work on the code using a version control system or a source code management system. So for example, a GitHub, a GitLab, all these platforms that I'm sure you all know. So the goal of this of this section would be to allow the developers to work distributedly and to host a unified version of the code. Then once we want to release a product, so the next phase would be to build the code that we have and to build the latest version. So this is what we call the build or the CI phase. CI is sort of a more broad sense of this phase that include other features which we'll discuss later. And then once the build phase ends and we have our output of the process and the binaries or artifacts that we would want to deploy, so there are a few options that we can do. We can either push them to an Artifactory and then tell our production environment to pull that and get the latest version, or we might be using a continuous delivery platform that might have several strategies on how it wants to deploy the code. So this is sort of a simplified SDLC that we would use in this webinar, and we'll go through the different phases. So the first phase that we will cover is tampering between developers and the version control system or the SCM. Then we'll move to tampering between the code and the build system. And finally, we'll move to tampering between build and this entire section here that we'll call our production. So let's start with the code. So what is a source code management system or source control management system? So it's a mechanism that allows a collaborative distributed development. Essentially, it also is responsible on the access control to the repositories that are hosted under it and the various role-based permissions, like who is a developer, who is an administrator, and things around that. And there is one protocol that currently dominates the market, which is Git. So probably most of the people here on the call, Git would be most relevant for them. This is the protocol that GitHub is based on, and GitLab and Bitbucket and Azure also offers it. So it's a protocol that is sort of in the center of modern day development. And for those of you who don't know the internals of Git, so there's a few phrases that we would like to introduce. So the first one is that change is represented by a commit. So each commit would hold the changes that the developers want to push. The next phrase is something that is called branch protection or branches. So the code is divided into several branches. Usually you would have the production and development branches. Obviously you can have other feature branches. Essentially it's a sort of a snapshot of the code that some developer is working on. And once a feature is complete, there is the process of merging this code into the dev or production branches. And there's a feature in Git for rewriting history. So essentially, the Git protocol, with its commit structure, has the ability to verify sort of the completeness and the integrity of previous commits. But there is a way to sort of change it, and it's called a force push, and it will essentially do some kind of rewrite. And then the last thing that is important to talk about when we talk about the code section is how you're using it. So the two options that we want to differentiate between is using a self-hosted option where you run an instance of the source code repository that you want to use on your own. So you could either run it in the cloud or you could run it on dedicated servers. But essentially you get sort of an image, let's say for example of GitHub, and you run it on your own, versus using the cloud offering of the public GitHub. So when we look at the threat model between each, so it's important to differentiate between the self-hosted and cloud. Obviously, for self-hosted, it requires a lot of management on the organization side. So you would need to update it. You would need to make sure that you're not using default credentials for the management itself, which is something that is not necessary in the cloud. but having a self-hosted instance gives you more security options and obviously more control on who has access to it. So what are the assets that modern code repositories hold, or the modern version control systems? So obviously the source code itself, the code that you're developing, the code that drives the business, and all the algorithm that you have. But it also has other important stuff that is important to remember. So the dependencies, so libraries that are used within your code base that are not the code that you develop. So this is something every organization has. Part of modern development is relying on these third-party libraries and open source tools to enable a faster development. So this is something that we would see in any project. And nowadays, you would have the CI/CD definitions. So if you're using a modern CI/CD tool, so usually you would have sort of a dedicated folder that contains the CI/CD definitions in the source code repositories. So for example, GitHub Actions or Circle CI, they all have a folder that contains the data that instructs the build system how to operate. Infrastructure as code is also something that we see more and more in code repositories, which are configuration files written sort of at a high-level language that describe the cloud resources that you want to deploy. So examples for this would be Terraform, CloudFormation, Kubernetes, and then because in modern development we are much more reliant on consuming services and using services. So a lot of times what we find in these repositories are the secrets that are used to access these repositories themselves. But not just that, we also find a lot of times the developers' credentials themselves, which is used for all kinds of scripts or things like that. Credentials to access the production environment, credentials for the build. So a lot of secrets find their way to the code repositories. And the last thing, which is sort of new, is a lot of security products that are now code-based. So if you're using static analysis or things like that, so they have an ability to add annotations in the code base to ignore something or to include something. So it's a part of a bigger section that's called the policy as code, but this is also a part of it. So now let's look at the code sort of from an attacker perspective, and if an attacker would like to tamper with the code repositories. So what are the options? So the first option to tamper with code is to get access to a developer's machine. If I have access to a developer machine, I can do things like the developer itself. So maybe I can change, maybe I can perform local code changes, but then this would be something risky because the developer might know this, and it's really hard to sneak in sort of these changes as part of its regular work. And I would have to target a specific developer that has access to a repository. So this is sort of a hard scenario to accomplish, even if I have access to the developer's machine. The next thing that I can do is I can commit through the developer machine itself. Obviously, there's the credentials there to do it, so I can create a commit straight through that machine. And the last option is still credentials. So it could either be still the developer credentials themselves, and then I can do it through a different machine. But I can also try to tamper with the source code through that. Essentially, committing through the developer's machine and stealing credentials that allow me to access, they become more critical when you have sort of a GitOps approach, and you're relying on automation, because, like Andrew mentioned in the beginning, if I have an automated path from my code to production, so an attacker might abuse that to sort of commit directly and get it to run there. Then, so this is the first option. But then I don't have to get to the developer's machine to steal its credentials. So there's many ways that developers' credentials can be stolen. So obviously the first option is a compromised host. So if I gained access to the developer's machine, the second option is a developer that exposed credentials somehow in a public domain. So a lot of time we see we found in public contribution, we find all kinds of developer keys that can be used to access the code. Another option obviously is phishing. So we see more and more developers being targeted at specific attacks, and phishing might be used to steal their credentials. And the last option is obviously brute force. So if they're not using a strong password or something like that, so it's also an option. And then once we have this capability, so we might be able to commit with the developer's credentials. Again, it's a problematic use case because if a code signing is enforced, so it could be harder. I need to find a developer that works on an interesting project or works on a relevant project. If I'm enforcing code reviews in my organization, so another developers can notice this during a review. If I have Slack notifications on such activities, so the developer might notice. So this is also a sort of a hard scenario. Then the next case is gaining access to the source code management system itself. So this is mostly relevant for self-hosted instances, whether it's on dedicated servers in your environment or in a cloud environment. So if these services are exposed to the public and are accessible, so someone might find it and try to get in. Essentially, to mitigate this risk, so Git has a built-in integrity mechanism. Each commit sort of knows that what are the commits before it and what are the changes in it. So it's hard to tamper on the file system itself in the source code management system. But again, a highly skilled attacker might find a way to do it. And obviously, if I gained access to the source code management system itself, so I can extract credentials and I can do all the scenarios that we talked about them beforehand. And the last use case that we cover is a supply chain attack. So when we look at supply chain attack that is sort of a developer focused, so we should differentiate between two main scenarios. One is on the dependencies that the project is using. So this is something that we increasingly see in the last year. And now projects are relying a lot on open source. And if I manage to hijack or take control of an open source project that is used by a target that I want to attack, so they load me as a dependency, and I can load the malicious code. So this is one option, and there are several ways to do it through open source. So it could be either a malicious contribution that developers had, or it can be hijacking of an open source project, or it can be something called a typo squatting, where I create a name that looks really similar to a popular package and hope that people will make mistake. But then the other aspect of supply chain attacks against developer is compromising developers' tools and developers' systems. So finding ways to abuse projects that they use or code development platforms. So this would all essentially give us access to the developer's machine, and then an attacker could utilize the scenarios that we've talked before. So if we look at past incidents, so there's a few that are worth mentioning regarding in what we discussed so far. So Sawfish was a phishing campaign that targeted GitHub users. When someone clicked the link, it would have a phishing page that would try to steal the developer's credentials. In 2003, there was an attack or an attempt to backdoor the Linux kernel, which is obviously something that is frightening. And essentially, because it was pretty long ago. So there were two version controls used, and one version control was compromised, and the attacker did a really sneaky change that he removed one equal sign that essentially gave them the access to run as the root user. So it was a really interesting use case. Then event stream and RubyGem are both attacks that are sort of a supply chain through open source tooling. So in event stream, the attacker took ownership of a project, of an open source project, and added a malicious dependency to that project, so that whenever someone was using event stream, it would also load the malicious dependency. RubyGems is a package manager for Ruby, and anyone can upload a RubyGem. So there's a lot of cases of having malicious packages in it that try to use the same tactic. XE, SSET, and Octopus Scanner are supply chain attacks targeted at developer tooling. The first one is related to Xcode, and it aimed at Xcode developers, so developers that develop on Mac, and used it to propagate. The Octopus Scanner targeted developers that are developing on developing NetBeans project, and also use that and GitHub to propagate. And even today, we heard Google just released that security researchers were targeted in sort of this social engineering attacks that try to make them run code on their machine and exploit them. So various reasons to try to get access to developers, and we see it happening. We see it in the wild. So what will be your ways to mitigate it? Obviously, run AV and EDR on the developer's machine. If it's compromised, you want to detect it and you want to prevent it. You want to enforce branch protections. So this would be this is a capability that exists in almost all of the modern source control systems, and it's something that you set in the repository level, and essentially gives you control over several really important policies. The first one is that people have to that code must be reviewed before it is merged to protected branches. You can have signed commits there. You can block the options to force push, which is essentially force push is rewriting the history. So this is something that you would want to enforce. You would want to enforce a strong authentication to the source code management system. So use MFA and SSO whenever possible. IP whitelist if you can, the access to the source control. Reach a least privileged access model, as we said before. So if we look at targeting a specific developer or gaining developers' credentials, so obviously this is a scenario. And if we have least privileged access, so an attacker wouldn't need to target any developer; they would need to find the right developer to do the tampering that they want. Dependency vulnerabilities, like we discussed, so have something to scan it and identify this issue. Monitor the SCM activity, try to identify anomalies there and any suspicious activity. And if you self-host your source control, so make sure to update it so that if there are any known vulnerabilities, they would be patched. And use the tool to protect access credentials from leaking. As we saw, this is a major asset in this scenario. These are a few examples of the mitigation we just discussed. So this is setting a require pull request on a protected branch, and the amount of approvals that I would want to have. These are the options that you can set other than just reviews. So signing commits, force push, and things around that. So not allowing history rewrites. Code signing is essentially just a quick explanation about that. So code signing is sort of a way for a developer to to attestate that they are the one that committed the code. So even if someone gains access to their GitHub access key, they wouldn't be able to sign their code in the BF, as like you would need to enter sort of this passphrase whenever you commit to prove that that you are the one committing, and the commit will be signed using your credentials to show that in fact it's your contribution. We got to the next poll.
All right, the second poll should be coming out to you right now. Which of the following mitigations are your highest priorities? You can select from enforce branch protection, strong authentication, MFA, SSO, IP restrictions, least privileged access, dependency vulnerabilities, or protect access credentials from leaking. Go ahead and make your selections, and just a quick reminder that today's event is being recorded. So if you miss any or all of it, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website, so you can always go find it there. You can just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, let's go ahead and close out this poll, and then we will take a look at the results. And oh boy, this one was a little bit closer. Looks like the following mitigations that are highest priorities. Dependency vulnerabilities obviously was the most, but followed almost very closely by strong authentication. Andrew or Ronan, do you guys have any comments regarding these results here?
I think they're interesting. It's cool to see enforce branch protection, which I thought is a sort of less known feature. But yeah, great.
So why don't we jump into a quick demo now of how you can protect some of these things. What we're gonna focus on here in the demo is basically a couple of quick things. The first is whether or not somebody should have access to your source control management system. The second is are you who you say you are? And so that is strong authentication. And the third is, what do you actually need access to? So there we're talking about least privilege. For example, when Ronan was speaking earlier and he talks about targeting a developer, well, if you've got an effective least privilege policy, now you've made that challenge much higher because you have to target the right developer. So those are the things that we'll focus on really quickly. What you're looking at in our tool is the ability to enforce policies in your source control management system, but not just one system. It can be multiple instances of the same GitHub. It could be on-prem enterprise and in the cloud. It could be GitHub and Bitbucket or Azure or GitLab. So you can enforce these policies across your entire organization, regardless of what source control management system you're using.
Thanks, Andrew, for the intro. So like Andrew said, I'll focus on the parts that we covered now. So really, the first thing that you would want to make sure is that, like Andrew said, the person still works for you. So for that use case, we have a policy that is called a SDL user in organization. What we do is we look for users that have no activity at all. If you identify such users, so from our perspective, they are SDL. This would be your past employees or past contractors, so people that don't work for you anymore. And we allow you an easy way to remove them from the platform, so you can select as many as you want, and you can remove them completely. Then the next phase is to have a strong authentication. So you would want, first of all, So first of all, you will want to make sure that two-factor authentication is enforced at the organization level, so that all your users have it. And if not, you will want to at least make sure that two-factor authentication is set for the users that you have in the organization. And finally, obviously, you would want to reach a least privilege approach. So since in the source controls, the repositories are managed sort of in a different way, and there's access to the source code management systems itself, but then there's the access to each and every repository that you have in the organization. So we look into that. We look at who has access to what repository and what is the actual operation that they are doing. And if we identify such access that is not used, so we would recommend you to either to reduce it or remove this member completely from a repository, which you can both do from this platform. Andrew, you wanted to add anything, or? Okay. So then we also covered the various configurations that you have at the repository level. So one thing that we've discussed is force push. So this is a setting that you will want to disable to make sure that no one can rewrite the history of your code repositories. So again, this is something that will help you identify if it's missing and also turn it on for the platform, or if you're integrated with our issue tracking, so you can create an issue through that. And then we also talked about branch protections. So if we identify repositories that don't have any branch protections enabled, we'll be able to let you know on that and allow you to turn it on through the platform. But then even if it's enabled, there's all kinds of ways to circumvent it. And so we look for that activity, and whenever something like this happens, so again, we're also able to let you know. And essentially, this is something that you would want to know about both from a compliance perspective and a security standpoint. The next model that we have is around secrets. So we saw how important our developers' credentials and how important it is to protect the secrets. So we monitor for secrets in code. The secrets might be secrets that give access to the interfaces, like your build or your production environment, or to the code repositories itself. So we look for secrets exposed in code. And this is a view that we show you all the secrets that you have across your entire repositories. But then we also scan the public activity of your developers, and we look for any credentials that might have leaked in their public contribution, so that if you have an exposed secret of your organization that somehow found its way to a developer account, we'll be able to identify it and alert you on that. Okay, so this is the first part of the demo. Any questions, Andrew, in the platform?
So actually, so far it doesn't look like we have any questions. So, and we're running a little short on time. So let's keep moving.
Okay. Okay, so now the next phase that we want to look at is the build. So assuming that we've managed to assure the integrity between our developers and the code repository, the next part would be the build process, which takes the code from the SCM, compiles it, and also a lot of other activities happen. So for example, testing the code, unit testing, integration test, security scans, the compilation itself, versioning, signing the code that we released, and publishing it to the Artifactory. So a lot happens in the CI or build process. This process can be automatically triggered. So a common practice nowadays is to say any commit to the development branch or the production branch triggers an automatic build. And just like in the code section, we also have the options here of self-hosting it ourselves. So having either a dedicated server or running it on our private cloud, or using a cloud-based solution. So when we look at the attack vector from this perspective, it's also important to differentiate between these two. So what do we have in the build? So really, the first thing we see that the build is sort of in the crossroads between the code and the production environment. So it has access to both. It has access to the code repository, and it has access to deploy to our Artifactory or to deploy to our production. So a lot of times we would find some way of having the secrets there. And if we're assigning our releases, so usually it will be in client applications that you sort of release a binary. So so you would also have the code signing certificates there. The code itself is hosted on the build, right? We needed to do the compilation, and here it would differ between what system you use. So if you're using a more modern system that sort of spins up a new container whenever it wants to build the platform, pulls the code, builds it, and then destroys this container. So this is something that will significantly decrease your the option of tampering with the code that is hosted locally. If you use a more traditional build system, so a lot of times you would have the code there, and it is a scenario. And the last thing that we have is the build configuration itself. So the configuration of what are the steps that I'm doing in the build, what piece of code is connected to which piece of code, what are the dependencies, so they would all be there. So when approaching of how can it be compromised and what are the scenarios around that, so again, the first option is someone gaining access directly to the build system, and this is mostly relevant when you build in a static environment, or if you build sort of if you have sort of a dedicated machine that the does changes and you only update the code whenever you want to perform a build. So in this case, the scenario of someone getting access to the build system is more relevant. And this is in fact what happened in SolarWinds. So assuming an attacker got access to the build system, so first of all, how can an attacker get such access? So they can find a vulnerability exposed in the service itself. So for example, if I'm using Jenkins, so there are vulnerabilities and it can be exploited to run in the source control. So this is why it's important to patch and update it. They can obtain credentials that have leaked. They can compromise the machine itself by compromising the organization and sort of laterally moving to this specific machine. And misconfigurations that might cause me to expose my build environment. So even something as simple as keeping the default credentials and leaving my build server open to the public would be something that exposes and kind of gives access to my source control. There's all kinds of other scenarios here. For example, the build can be open and people can sign up, but I won't go into that. And then if an attacker has physical access to the build system, so what they can do. So first of all, an attacker can extract the secrets, both to access the code into production, if it's hosted on the machine itself, and it probably is in some way. It says the attacker has sort of physical access, so there's ways to extract them. And an attacker can also do malicious changes, so change the build configuration, change local files, or advanced attack, which is what happened in SolarWinds, where the attacker actually sort of hooked the build process, and whenever it's fired, they replaced a specific file on disk. So it would be a more advanced scenario. The next option, which is relevant to both if you're having a dedicated server or using a cloud offering, so is obtaining credentials. If you have credentials, so you can maybe play with the build configuration, and maybe you can extract some secrets. A lot of time there's the options to add scripts, and in some cases you can steal credentials and certificates. So a few examples of sort of risky configurations in CI/CD tooling and build process. So for example, we see this configuration which says build for pull request, and there's an option to pass secrets to builds from a fork pull request. So essentially what it means is, even if I have the branch protections set in my source controls and I protect all the code in the repository, if these two options are enabled, so an attacker with access to the source control can create a fork of my repository. They can do in that fork, they can do whatever they want because it's sort of an instance that they manage. And then once they push it, the CI system would identify it and would pass the secrets and run this build process in the context of my SDLC. Another thing that you have in every build and CI system is the ability to sort of run specific actions or orbs, or it depends on the platform you use the naming. But essentially, you can run certified orbs in this example, or uncertified. Uncertified would be orbs that just like the name suggests are not certified, and essentially it's also a way that an attacker can use to sneak in code to the build process. There's several build systems that allow you to define specific scripts, and that would be part of your build process. So just by having access to the build system, assuming this option is there, I can add scripts of my own that will now run as part of the build process of your product. And this is another example of having scripts as part of the build process. And the last use case that we need to remember when we talk about tampering with the build is that now a lot of the build definitions and build instructions are now sitting in my code repositories. So now an attacker that wants to tamper with this process can also have the option of changing these files, and it would effectively change the way that the build system works and change the operation that it does. So these are assets that we need to monitor and make sure that they are not tampered with, again, as part of protecting the build. So an attacker can inject malicious content just by changing this code and run as part of the container environment that builds my code, abuse the production access, add malicious packages, and other advanced scenarios. And just a few examples related to build compromise from the last year. So obviously we have SolarWinds, where the Sunspot malware, which is the malware that was used to tamper with the build process, was unidentified. It monitored the running processes to identify the build itself and then replaced a single file on the machine. In 2017, we had the CCleaner incident. So in the CCleaner incident, an attacker hijacked sort of a developer's TeamViewer account and gained access to the internal build and modified the CCleaner software. Essentially, it got to the update mechanism and distributed to millions of people, but the attack wanted to reach a specific group. So there's actually several stages of the attack, and each time the CCleaner ran, it tried to identify the machine that it's running, and if it was interesting, it moved to the next phase. So this is also the CCleaner incident was related to the build process. And the last one that we'll discuss here is WebMin. So WebMin is this web-based system configuration tool for Unix-like systems, and a vulnerability was secretly planted in the build server that was actually sort of hosted in one of their members' device. So this is another example of how build tampering could result in a supply chain attack. So what are the mitigations there? So one mitigation is to move to what is called the ephemeral or immutable build system. Essentially, instead of having this physical build server running either in your cloud or your on-premise, to use a system that every time it wants to do the build, it spins up a container that you can verify and that you can make sure that you can verify its integrity, and it only contains like the various packages that you need to build your product. Then it does the build, it pushes your artifacts, and it kills the container. And essentially, in this use case, it's much harder to accomplish things like how SolarWinds was compromised. If you're not using that, so obviously if you can run an AV or EDR on the build server itself and identify any malicious activity or tampering. Again, strong authentication to the build process, MFA, SSO if you can, IP whitelist the access to the build. Probably not a lot of people would need it. Least privilege access to the build systems itself. if you're self-hosting it, so update and patch it on your own. Monitor and identify anomalies in the build, and obviously protect the access credentials from leaking. And we're in our next poll.
All right, let's go ahead and push out that polling question now. Which build mitigations are your highest priorities? You can choose from ephemeral immutable build system, AV/EDR and build server, strong authentication, MFA, SSO, IP whitelist, least privileged access, or update and patch build system. You can go ahead and make your selection. And in about 20-25 seconds or so, we'll go ahead and close out the poll. But just a quick reminder, if you got a question, now's the time to send in your question if you do have one. And hopefully we'll have a minute or two near the end to go over any questions. All right, let's go ahead and close out this polling question. Take a look at the results. Okay, it looks like least privileged access is the clear winner with this one. Do you guys want to make any comments, or should we just keep moving along?
Yeah, I think we'll move along since we're short in time.
Okay.
But to me, my only comment is I love the fact that ephemeral immutable build system got a high score also. To those of you who are interested in the subject, so there's this whole concept of resilient systems that I recommend to read more about. And the notions called the reproducible builds, again, for those of you interested. So then we move to the next section, which is the production environment. So when we talk about the production, again, we included here the Artifactory that holds the output of the build process. We talk about the continuous delivery system, so the process of updating the production environment with the build artifacts. There's all kinds of strategies that you can do, and it's obviously more complicated, but we try to keep it simple. And if you're using a SaaS application, so probably your latest code is running in the production environment itself. But if you're developing a client application, so you would probably have sort of an update server that you would run in production that has the latest binary that you want to distribute, and that clients periodically questions to get the newest version. So this is what we look at when we do the sort of modeling here. So the assets that you would have in your production, obviously commercial and personal data exist in this environment, access to the infrastructure itself. That might be interesting for an attacker, like run miners on your infrastructure, things like that. Secrets and keys that can be found in your production environment and can be used to move to other services. Code, so a lot of time, and we will see it in the cases that we'll show here, but code that is hosted in production environment can also be tampered with and used for a supply chain attack. The applications itself that you're running, so to replace them or to have a malicious update, and like we saw here, so SDLC tooling, right? If I'm running my GitHub instance in my cloud, so this is also something that might be accessible from my production environment. So how can the production environment be compromised? So the first option is obviously misconfigurations. So all kinds of ways to misconfigure the cloud assets and define open access to them would give people access. So what can an attacker do if he has access to my production environment? So they could compromise code if I'm using functions or things like that. So it might exist there. It can create resources, so run within the context of the production environment. And it can abuse the access either to export resources or to modify content. So aside from misconfiguration, which is a way to expose the production environment, so an attacker can try to gain access through secrets or credentials, so use them to access the production environment, or again by supply chain attacks, so run in the context of my production. And the last use case here again, and it ties us back to the code section as well, is infrastructure as code tampering. So the infrastructure as code would define my production environment, and tampering with it would essentially result in tampering with the production environment itself. So just a few incidents here. So we have the Capital One breach is not a supply chain per se, but essentially it's a combination of misconfiguration that exposed access to sensitive data. We have the MacArt group, which are known to abuse this environment. So two interesting use cases here. In 2019, they sort of hunted and sprayed for an open S3 bucket. Whenever they saw a bucket that hosts a JavaScript file, they injected into this JavaScript file, and essentially, once the application consumed this JavaScript code, they started mining. So essentially, this is one tactic that they used. The second one was used on British Airways, where they managed to get access to the production website of British Airways, and in the payment section, injected code that harvested the customer payment data. And the last example that we give here is around ASOS, which were targeted, which were affected by a supply chain attack called Shadowhammer, which essentially attackers gained access to the update server and their certificates, and created a malicious version that was used to update ASOS clients. So the mitigations here, again, use strong authentication, reach to a least privileged access model, use cloud security posture management to identify any exposed assets, monitor for suspicious activity, scan infrastructure as code files, and protect, obviously, credentials that give access to your production environment from leaking. Then we got to the last poll. I know the production was really quick, but I try to, we're running out of time.
All right, here you go. Hold on. Sorry, did I
This is the right one.
the right one? I think, yeah, this is the right one. Okay, all right, great. I got confused there for a second. Okay, so which production mitigations are your highest priorities? Select from use strong authentication, MFA, SSO, IP whitelist, least privileged access model, use cloud security posture management, monitor for suspicious activity, or scan IAC files in code repositories. Yes, we are 3 minutes to the top of the hour, so I want to give everybody just a second or two to go ahead and make your selection, then we'll close it out, and we'll go ahead and close it out now in 5, 4, 3, 2, 1. All right, sharing the results now. Using strong authentication was definitely the clear winner with this one. So any thoughts, or should I go ahead and close it?
No, I think we can continue. For us, let's just sort of wrap up what did we discuss so far. So we talked that when you look at the SDLC security, you look at several things. First of all, the integrity between what your developers are working and the code repositories themselves, making sure that the code that they write is what you have there. Then you want to make sure that the build happens through the code that you have in the code repositories. And finally, make sure that what is actually running in production are the outputs of the build system. And essentially, what we also saw is that sort of the lines between these different phases have kind of blurred over the years. The code now holds the definitions for the CI, the CI CD tooling. It holds the definitions for my infrastructure as code, for my infrastructure as code and production environment, and essentially vice versa. So compromising the build system would give me access to the code and would give me access to the production. And we keep seeing almost every month we see a new incident that is involved with one of these phases that essentially results in either code compromise or leak. For example, Git folders extracted from production website that sort of gives access back to the code and reveals secrets. So these things happens all the time. So it's essentially important to protect the entire process and identify what is your weakest link and keep improving on that. I think we don't have time for the demo. Are there any questions, Andrew?
I think we need to pass it back to Charlene to do the raffle.
Yes,
Okay.
well, we have actually chatted out today's Amazon gift card winners. It is the top of the hour, so unfortunately we do need to close out the question or the webinar. But if you had a question and you did put it in the control panel, please know that the folks at SciCode will be getting a copy of all the questions. So you will get an answer to your questions. I'm sure they'll be more than happy to follow up with you offline. I do want to thank Ronan and Andrew for a very informative and information-laden webinar. What a great one. Thank you so much. Maybe next time we make it a two-parter webinar so we can get all the information in there. But yeah, good stuff all the way around. Thanks a lot, guys. Really appreciate it. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody, and please stay safe.
Thank you,
everyone.
Bye-bye.